Okay, my name's Mike Brunt, my company's Go to Rear, and this is the third in a series of short videos really to show what we do day in, month in, year out to help people to get better performance out of their applications and to hunt down the causes of problems, and they're all different at different times. In this particular series what we're showing is the effect of identifying a problem, in this case a problem URL, and using external caching, front caching, to bring improvements. So we're now running the third test in this series, and we've got the results from what that brought about, which is quite interesting to see. So without further ado, let's move in and look at the results. Hopefully you'll be able to read them all right. Yeah, so what we have here is now three sets of results. The first test is this first set of results here, and I already pointed out that we have this terrible URL, but this is without caching, which was taking 66 seconds and generating 50% of errors. The second set of results that we had was the exact same test, so that's 15 concurrent users running for 5 minutes with 8-second think time, and with external caching on, front caching, that's in between the router and or firewall and the web server called Fusion Server. We can see the second URL in this series. I mean, the difference, which is the one causing the horrendous problems here, the difference is dramatic. We have from 66 seconds to 48 milliseconds. The result of that test is we ran 450 clicks during the duration of the test, which is 5 minutes, and the average click time was 1.8 seconds. So the next thing we move on to, which is the third set of results, is we double the number of concurrent users to 30. So we now have 30 concurrent virtual users running for 5 minutes, 8-second think time. Once again, the problem URL, and this is really important to note, which was URL 2 in this first test without caching, is still at very low 48 milliseconds, which is something that you would expect because the caching mechanism has actually brought the relief in this case, and it's still great even though we double the number of users. What isn't great is we now have other URLs cropping up which are causing problems, and one in particular, which is URL 5. This is the one that we mentioned, which is a chart and which is not cacheable because it's dynamic with every request. So this has now jumped up to 48 seconds, still no errors. But the overall point of the result of the test is we go from 450 clicks with 15 users to only 589 clicks with 30 users, which is twice the number of users. So you would expect in a healthy system to get at least somewhere near twice the number of clicks, but we don't. And the actual response time overall degrades from 1.8 seconds to 7 seconds. So this is a classic example of some other sort of bottleneck causing a problem. So we're now going to take a look at the CPU behavior during the running of this test, and that's what we're going to look at now. And this is on the web CF server, so this is the actual server running that the test is running against. We can see here this top graphic here. Those who are familiar to Windows will be familiar with this, but I'll describe it. This is the actual CPU behavior during the test. We can see at the moment it's sitting at 100%, just dropped a little there to 75. So there is no doubt now what we're hitting here, we can be fairly certain we have some sort of CPU problem, some sort of overall problem which is causing the CPU to hit 100% and sit there. And of course, once the CPU is at 100%, your resources degrade. I mean, any of us that have tried to, for instance, play a computer game when the CPU's up the wazoo, if you pardon the Lancastrianism, it doesn't work very well, and that's what we're seeing here. I mean, the processors on the system are bound by CPU problems. So that's really the summary of the tests so far. In what we've been able to see is we ran a first set of tests with no caching and had tremendous problems. We couldn't get past 15 users without being 100% error. We ran a second set of tests with caching on, and we were able to run with 15 users, same number of users, with no errors at all, and 1.8 second response times, which is really dramatically better, and no errors. And then we ran a third series of tests where we tried to double the number of users, because now we're pushing on for the client and we're saying we've solved the problem that you had in the first place. Now we want to get you to a respectable number, so we double the number of users, and what we find then is we start hitting another bottleneck, and that bottleneck turns out to be the CPU resource of the server itself. So these are really real world tests that I've run many times, or we have as a company, and they actually do produce results. And we would, in this case, we would now dig down to find out why the CPU is hanging at 100%.